sure. It's unit 1, so let's do the first one. Which of the following is equivalent to the absolute value of x over x when x is greater than 1? All you have to do on this problem, let me go ahead and close this out real fast. Okay, all you have to do on this problem, what is the absolute value of x? X, remember it's positive, over x, let's reduce the fraction. X over x equals 1. And the correct answer is E. All you have to do is simplify that absolute value. The absolute value of x is x over x. X over x is 1. This right here is just letting you know that x is going to be a positive answer. So you know that these answers, like this is a positive x and this is a positive x. Without this information, you might think that it could be -1 because this x value could be negative if not specified that it's positive. All right, number 2. If x and y are real numbers such that 0 is less than x is less than y squared, which of the inequalities must be true? This problem looks very challenging, but if you pause and look right here, x is less than y squared. What I want you to do is just pick some answers. Let's say x is 2 and y is 3. So if I substitute, I'm going to get 2 is less than 9. Looking at my answer choices, if I look at option E, x is less than 3y squared. If x is already less than y squared, x is definitely going to be less than 3y squared. So if we were to plug that in, we would get 2 is less than 3 times 9. 3 times 9 is 27. 2 is less than 27. That's definitely true. If x is less than y squared, x will always be less than 3y squared. So don't overcomplicate it. Just look at the problem and kind of analyze your answer choices from there. Okay, number 3. If p and q are real numbers such that pq squared equals 4, which of the following statements must be true? So looking at our answers, p times q is greater than 0. Well, things you need to remember. Anytime that you square a number, you could also use -2. You could also use -2. And the reason is because when you square any kind of number, when you square a positive or a negative number, your outcome will always be positive. So p times q could be positive, greater than 0, but it could also be negative. So pq could also be less than 0, making A incorrect. Let me fix that q. PQ equals 2. Well, that is true because 2 squared has to equal 4. But remember, P times Q could also equal -2 because -2 squared is also 4. P is greater than 1 and Q is greater than 1. That does not have to be true. So let's test option C right here. P could equal 1/2 and Q could equal 4. Because 1/2 times 4 squared would still be 4. Half of 4 is 2. 2 squared equals 4. So P in this scenario is 1/2. P could be less than 1. So this here makes it to where that doesn't necessarily always have to be true. P is less than 0 and Q is greater than 0. That's saying that P is negative times Q, which is positive, squared. Well, that would work. However, Q could also be less than 0 because a negative times a negative squared is still going to give me a positive answer of 4. So by default, the correct answer is E. Number 4, if the equation absolute value of x minus a equals the absolute value of y minus a, which of the following must be true? Sorry about that, Belle. I'm doing this in between classes. Okay, so to do this problem, I'm going to analyze my answer choices. Hopefully, we can see that option E is literally the same equation, just flip-flopped and rearranged. So all they did here, so I'll build my absolute values into my problem. To get -a plus y, they just took this part and moved it here and put the -a first and the y second, and then they took this and flipped it over here. -a plus x. They are literally the same thing, just flip-flopped around. So they really didn't change the value at all. They just rearranged it. So that's why it's E. Okay. This question is a great question. It is fancy substitution, which is what I like to call it. This arrow does not mean anything. So I don't want you to panic and start trying to figure out what it means. It means literally nothing, okay? It's called fancy substitution because if we look here, X, arrow, Y, and then I look down here, X, arrow, -1, notice that the Y has been replaced with -1, which means when we go to our fraction of Y over X, it just means I'm going to replace Y with -1. And we're looking for an answer that is always going to yield a positive number. I always want a positive number in this case because it says always positive. Well, the only way to get a negative numerator to equal some kind of positive number is to put another negative number underneath it. The only the only inequality that represents only negative numbers, that's the important part here, negative numbers, it only incorporates negative numbers, is option B. X is less than 0. I don't want to pick this one, less than 1, because I could use 0.5. That's a positive number. Option B ensures that I'm only using negative numbers, making that fraction reduce to a positive. All right. Number 6. Okay, I just realized that this pen is like bleeding terribly. Hopefully it'll be okay. All right, number 6. Let A weird mark B equal B squared minus A squared plus 1. And notice here, again, fancy substitution. A is -2 because they're listed in the same location. B, -3, listed in the same location. So all I'm going to do is substitute. -3 squared minus, parenthesis, -2 squared plus 1. -3 squared is 9 minus, -2 squared is 4 plus 1. -9 plus 1 is 10, minus 4 is 6. Option D. Be very careful when you're substituting. You want to make sure that you're putting parentheses when you're squaring. That's why they're giving you negatives. But again, this symbol means nothing. It is fancy substitution. Number 7, literally the same thing. X delta Y, 7 delta -2. So that means this is my X value, this is my Y value. Fancy substitution. So I get 7 plus 1 over -2. 8 over -2 is -4, which is option A. Don't get confused, okay? It's just a way to make the problem harder. Instead of saying X equals 7, they're just putting it into this code that you just have to decipher, okay? Nothing too challenging. Same thing with 8. So we have A circle B, -2 circle 1. That means -2 is A and B is 1. So I get 2 times -2 minus 3 times 1. 2 times -2 is 4, minus 3 is equal to -7, which is A. Fancy substitution. Number 9, if the value of 4m over 4n is smaller than 1, which of the following must be true? All right, so looking at this answer, okay, this value has to be smaller than 1. Well, if it's smaller than 1, that means that we have a fraction that has a denominator that is larger than the numerator, making it smaller than 1. So if we look at our answer, our goal here is to have a denominator that is large. We want a larger denominator and a smaller numerator. For example, 1 over 16, that is less than 1. 3 over 2 is greater than 1. So notice here, the denominator has to be larger than the numerator for the fraction to be smaller than 1. So this is our goal. We want to think big denominator, small numerator, okay? So the only way to do that is option D. If I make m smaller than n, so let's make m 3, and we'll make n 5. So notice how m is less than n? Well, to simplify that, remember we subtract our exponents. I would get 1 over 4 squared, which is 1/16, which is less than 1. So we want to make sure that the numerator exponent is smaller than the denominator exponent. Smaller, larger. The only one that fits that scenario is option D. All right, number 10, if 3 to the m equals 1, what is the possible value of m? Here is the trick. Remember, any number to the 0 power is 1. So 3 to the 0 is 1, meaning the value of m, or the value of my exponent, has to be 0. Anything to the 0 power is 1. Again, you could also just plug and chug. You could use these answer choices and plug it in. You would see that option B gives you 1. Okay, if 3p over 3q is 81, which of the following statements must be true? Okay. So the sum of p and q must be 81. The difference of p and q must be 4. Both p and q must be integers. Both p and q must be positive. Either p and q must be positive. Anytime you're dealing right here with fractional exponents or fractions and exponents, remember the rule. 3p over 3q can be simplified to 3p minus q. Okay. Now, this p minus q answer must equal 81. Notice how I have p minus q, which means difference. So if the difference must be 4, I would test it. 3 to the 4 does equal 81, making B the correct answer. Test your answer choices. Remember, this is a way that the ACT will test your exponent knowledge. You can do it, just don't overthink it. Okay, number 12. If 2 to the m equals 41, which of the following must be true? Okay, so 2 to the m is 41. We're trying to figure out the possible values of m. So what I would do is I would put 41 in the middle. I would put 41 in the middle, and you're trying to figure out some values. So this is 2 to the m. I would now plug in, we can make these x's and these y's. I would make this 2 to the x and this 2 to the y, and then I would test my answer choices. Let me grab a pencil here. I'm also going to show you how to do it with logs, but we haven't talked about logs yet, but I will show you. So right here, I'm going to make this x value 1. So 2 to the 1 is 2. Okay. And then this is my y value, so 2 squared is 4. Well, 41 is not between those two, so it's not those. And then you would just continue to test. The correct answer is E. So 2 to the 5, 2 to the 5th power. Oh, that does not look like 2 to the 5th. This is 2 to the 5. 2 to the 5 is 32. This would be 2 to the 6th, and 2 to the 6th is 64. 41 is between these two values, so E is the correct answer. Now, you can also use logs, which we haven't talked about, but if you remember them from Algebra 1, totally fine. Okay. So right here, you would go 2 raised to the 41, or log of 2 of 41 will equal m. So if you're on a TI 84 plus, you would go to math and option A. Again, we haven't learned it yet. But we will eventually do this. Let me find. I might have to re-look that up. Okay, here it is. I'm sorry. It had been a second. So this will work on the 84 plus. To change the base to 2, what you can do is go to math, arrow all the way down. That's why I was going crazy. Log base. My base is 2, this is 41, and I get 5.35, which is in between 5 and 6. So if you have an 84 plus, you can do it this way. Again, we haven't talked about logs, so I definitely don't expect you to know how to do that. It's okay that you don't. Let me see if I can zoom this in. Oh, well, I can't. It's fine. So all you're doing here is using your calculator. If you don't know how to do it, you can always test your choices. All right, 13. If 0 is less than x is less than 16 to a half, and x equals 2 to the m for the positive integer m, what is the value of x? Okay, all you have to do here is we're looking for positive integers. That's important. Okay, positive integers, which means it can't equal 0. Okay, can't equal 0. So all we're going to do here, let's simplify. 0 is less than x is less than 16 raised to the half is just 4. Okay, you're looking for the value of x. Okay, we're looking for the value of x. So all of these choices here, okay, x equals 2 to the m for some positive integer, the x value has to fit right here. Okay. All of these answer choices, what we're going to do, we're going to replace x with 2m. Okay, 2m. Because we know that x and 2m are the same. What I'm going to go ahead and do is plug in my answers. Well, let's say m is equal to 1. So let's make m equal to 1. X equals 2 to the 1. Because all I'm doing is I'm using this formula right here and I'm plugging it in. X equals 2 to the 1. So x is 2. Which means my answer for the value of x is option B, 2, because it is between. Okay? I'm looking for a value of x, which means it cannot be 4 through 6. That number for x is greater. 4, it can't equal 4. It has to be between 0 and 4. So C, D, and E are just totally out to begin with. Now, the reason that x isn't 1, okay, the reason it's not A, and I think there's some confusion here because m is equal to 1 in this case, and you want to pick A. For x to equal 2 to the m and for x to be 1, 2 would have to be raised to the 0, and it clearly says a positive integer, which means that it cannot equal 0. Okay, that's why it's not A. We're looking for the value of x, which is B, 2. It's a very tricky problem. That problem is confusing. 14. If 2 to the negative m equals 1/8, what is the value of m? All you have to do on this one is use your exponent rules. So 2 to the negative m is the same as 1 over 2 to the m equals 1 over 8. If you cross multiply, we get 8 equals 2m. So you're trying to figure out what power do I raise 2 to to get a answer of 8. A and B are out. We're not raising them to negative powers. We should know that 2 to the third power is 8, which means my answer is 3. Option D. 15. Same type of problem. Same type of problem. So I get 1 over m to the 3 equals 64. Okay, 1 over m to the 3 equals 64. I'm going to cross multiply. So 1 equals 64 m to the third. I cannot cube root yet. I have to divide both sides by 64. So I get m to the third. Now, you can cube root on your calculator. So when m is isolated, cube root. When I cube root those, the way that you do cube root, you go to math and option 4. It automatically will have the cube. I'm going to type my fraction. Oh, I don't need that. I get 0.25. 0.25 is 1/4, and that is the value of m. Do not pick option C because the answer wants it to be 8 times m. So 8 times 1/4 is 2, which is my answer, D. Be very careful. You have to do additional things in this problem to do it right. Okay, 16. If 2 to the negative 1/2 raised to the 4y equals 1/8, then what is y? Okay, first thing I would do, distribute the 4y. So I would get 2 raised to the negative 1/2 times 4y. So let's combine that first. This is technically over 1, so I get 2 to the negative 4y over 2. which simplifies this fraction. We're still simplifying. 4 divided by 2 is negative 2y. So all I did was I distributed my power. It's power to a power, so I'm going to multiply. And then I just simplified the fraction to get negative 2y. Now I'm going to simplify even more because I don't want negative exponents. So I'm going to get 1 over 2 to the y. And now I'm going to bring down the 1/8. Okay. Cross multiplying, I will get 2 to the 2y equals 8. Well, we should know that 8 can also be written as 2 to the 3rd. 2 to the 3rd is 8. So we're trying to figure out our potential value of y. When you have the same bases, you can set the exponents equal, meaning 2y must equal 3, because remember, the bases are identical. Dividing by 2 would give me y equals 3/2. So my value of y is 3/2. Okay, on the back, 17. If 3 to the 0 equals 1 minus n raised to the negative 3, then n equals blank. So 3 to the 0, let's go ahead and simplify that to 1. This has a negative exponent, so I'm going to put it in the denominator of my fraction, making it positive. Okay. The denominator, okay, this fraction must equal 1. Okay, this fraction has to reduce to 1, which means my denominator has to be 1. In order to get a fraction like this, to simplify to 1, my denominator has to be 1. 1 over 1 simplifies to 1, which means I am going to set this answer equal to 1. Because in order for my whole fraction to reduce to 1, the denominator has to match the numerator. So I'm going to get 1 minus n to the 3rd equals 1. Now I will cube root, and then I will be left with 1 minus n equals 1. Subtracting 1, I will get negative n equals 0. N has to equal 0. When n is 0, so I can go ahead and plug it in. 1 equals, here I'll draw this an arrow. 1 over 1 minus 0 to the 3 is 1 over 1, which is 1. Okay, all you're doing is setting the denominators equal. Number 18, what is the greatest common factor between 30, 90, and 130? The greatest common factor that goes into both of these is 10. So if I were to pull a 10 out of here, I would be left with 3. If I were to pull a 10 out of 90, I would be left with 9. And if I were to pull a 10 out of 130, I would be left with 13. We know that 10 is the greatest common factor because 3, 9, and 13 have no other common factors between them, so 10 is the largest. 19. The remainder when an integer m is divided by 2 is 1. What is the remainder of m plus 1 divided by 2? So let's take this back in time. Let's do a little example. Let's say that we have 3 over 2. 3 over 2 gives me an answer of 1, so 2 goes into 3 one time with a remainder of 1, okay? Now, let's try 4 over 2. 4 over 2 goes in 2 goes into 4 twice with a remainder of 0. So we're taking it back to elementary school when you first learned how to divide. Now let's bring it back up to high school. M is divided by 2, and the remainder is 1. So I get some number with a remainder of 1. What is the remainder of m plus 1 when divided by 2? This is literally the same idea. I can rewrite 4 as 3 plus 1 divided by 2. If I'm dividing by 2 and I have a remainder of 1, that means that the number is odd. 3. I could test it again with 5. 5 over 2, 2 goes into 5 twice with a remainder of 1. If the number is odd and I'm dividing by 2, I will always have a remainder of 1, which happens here. But if I add 1 to that, it makes it an even number. So if I add 1 to 5, I would get 6. 6 divided by 2 is 3, with a remainder of 0. So my remainder will be 0 because my answer is even. Okay, just think about it in terms of middle school, elementary division, and then bump it up to high school level and think about what that means. You would just get a number with a remainder of 0 because it's even. Number 20, if the fraction a over 25 is simplified, is in simplest terms, which cannot be a factor of a. This problem, I promise, is not as hard as it looks. So in this problem, a over 25 is as simple as it can get. The factor that cannot be with a has to be 5, because if a has a 5 in it, I could reduce it further because 5 goes into 25. So that's why the correct answer is A. 5 is divisible by 25, so it cannot be a factor of A. Or I could simplify it more. All right, 21. 3 and 2 are factors of A. So 14 times A right here. We're looking for what could be a factor of it. Well, we know that 3 times 2 is the factors of A. We could break down 14 into 7 times 2. To figure out which one of these answer choices must be a factor of this, let's multiply them all together. 7 times 2 times 3 times 6 gives me an answer of 84. When I divide 84 by 4, remember factors have to go in evenly. So 84 divided by 4, I get a whole number of 21, which means that, not 24. Again, the answer is 21, which means 4 is divisible. If I were to continue this trend with the other numbers, 84 divided by 5, I get a decimal. Can't be a factor. 84 divided by 8, decimal. 84 divided by 11, decimal. 84 divided by 19, decimal. The only one that does not give me a decimal is 84 divided by 4. And the last problem, if m is a number of distinct prime factors of 100, what is the value of 3m? Distinct primes mean the numbers don't repeat. So let's go ahead and do prime factorization. Okay, prime factors, that's key for prime factorization. I'm going to break it up into 10 times 10, 5 times 2, 5 times 2. Now, distinct factors means I only count it once. So I have a 5, which is one factor. I have a 2, which is another factor. Oh, I shouldn't use tallies. I've got 5 and 2, which means the number of distinct factors or different numbers, I have 2 of them. There are 2 distinct prime factors. Distinct meaning that they are different numbers. I have 2 distinct prime factors. I want to know what 3 times m is. The 2 represents m. So I'm going to do 3 times 2, which is 6.